Good morning, everyone. Today we're looking at Unit 6, Lesson 5, Solving Problems with Vectors. So today is really just a continuation on the idea of adding and subtracting vectors and looking at some examples in terms of word problems. So let's recall a couple things. First of all, when two or more forces act on an object, you can use vector addition or vector subtraction to find the magnitude of the resultant, right? So by adding two vectors together or subtracting a vector from another vector, you can figure out what is the length of that resultant force or resultant vector. In terms of the direction, so the direction of the resultant can be found using trigonometry. So SOHCAHTOA, sine law, cosine law, Pythagorean theorem. The direction may be expressed as an angle relative to one of the given vectors. So if we're talking about a triangle or in terms of the horizontal, the angle might be given in that manner, or as a quadrant bearing. So that's looking at it on a compass and then determining from that north-south line the angle made to the east or west of that. So let's look at a few examples. I'm going to do a lot of setting it up and then pausing it and letting you guys work through it. So Mary is walking to the library, which is 3 kilometers east and 2 kilometers north of her current position. So let's draw what that's going to look like. So let's just say that Mary is at the origin of a compass, right? She's going to walk 3 kilometers to the east, right? So 3 kilometers to the east. And she's going to then from there walk 2 kilometers north. Okay, so determine the magnitude of the resultant. Well, we know the resultant will be from the tail of the first vector to the head of the second vector. So that's our resultant. Okay, so go ahead and pause the video and use what you know about trig and vector addition to figure out what's the magnitude of that resultant. Okay, so there's your answer. We have two sides of a right triangle. Make sure we know that's a right triangle. We should be able to find the third side of that by using Pythagorean theorem, which is essentially adding those two vectors together to figure out the magnitude of the third one. Okay, so we apply Pythagorean theorem, add the sum of the other two sides, and then square root that sum to figure out what r is equal to, and we get 3.6 kilometers. Okay, the next part says to determine the quadrant bearing. So we have to, again, make sure we know where the quadrant bearing is. So our quadrant bearing is this piece right here, right? It's between that north-south line and an east or west direction. So this is our quadrant bearing. Okay, but with the triangle we have, we can figure out our theta, and then we might have to use that information to help us with our quadrant bearing. So if we're trying to figure out what theta is, we can again use trigonometry to do so. So we have some sides here. We have our opposite and our adjacent side that were provided to us. So let's go ahead and use our tangent. So the tangent of theta is going to equal my opposite over my adjacent side, which in this case is 2 over 3. And then to isolate for theta, we're going to take the tan inverse. And we should find that theta is equal to 34 degrees. Now that's theta, but we want our quadrant bearing, so we're going to have to figure out what is the distance from that 34 degrees to that north line on our compass. So we'll have to subtract from 90. So our quadrant bearing is going to equal 90 minus 34, which is 56 degrees. Okay, and we can see that that's in a northeast direction. So we can say, therefore, the resultant is 3.6 kilometers on a quadrant bearing of north 56 degrees east. Okay, let's look at another example. Again, we'll do the setup and I'm going to pause and let you guys work through it. So a person pulls a sleigh exerting a force of 200 newtons along the rope that is at an angle of 35 degrees to the horizontal. So let's first try to draw that. So if I was going to draw, very poorly because I can't draw, a sleigh. So this is my sleigh. And then there's a rope attached to it. Right, so we have a rope attached to our sleigh. Okay, and it's being pulled at a force of 200 newtons. That rope makes an angle with our horizontal of 35 degrees. Right, so that's the drawing we have so far. It says find the horizontal force that moves the sleigh forward. So remember, we looked at this in another lesson where we looked at the horizontal and vertical force. So let's just remember, what did we use to identify our horizontal and our vertical? Well, our horizontal, just like we would on a Cartesian plane, is represented by x, and our vertical is represented usually by y. So this represents our vertical force, and x is going to represent our horizontal force. So given that information, go ahead and answer A, and then part B to this question is on the next page. So try to work through A and B, and then we will take it up together. Okay, so when we're trying to find the horizontal force, we're going to use cosine because my horizontal force is represented by the adjacent side of my triangle, and then we also have the hypotenuse we're working with. So we set up for cosine, and then we rearrange, so we find that the x vector is equal to 200 times the cos of 35, which is 163.8 newtons. If we're trying to find the vertical force, this time we're going to use sine because my vertical force is my opposite side in my triangle, and then again we have our hypotenuse. So we can see that the sine of 35 is equal to my opposite side, which is the y vector, over 200. If we rearrange for y, we're going to find that y equals 114.7 newtons. Let's try one more example, and that's it for the day. So example 3, Matt and Mark are playing in a soccer game. Mark kicks the ball downfield parallel to the sideline. Then Matt kicks the ball 20 meters further at an angle of 38 degrees to the sideline. So it says determine the magnitude of the resultant to the nearest meter. So let's just first try to draw a sketch of what's going on here. So it says that Mark kicks the ball 30 meters down the field parallel to the sideline. Well, let's first just draw our sideline. So if this is our sideline, our soccer field, Mark's going to kick it down the field parallel to that sideline, so something like that, 30 meters. Okay, then Matt's going to kick the ball 20 meters further, but it's going to be at an angle, so we'll try to make some angle. Okay, he's going to kick it 20 meters further, but it's going to make an angle of 38 degrees. This is 38 degrees to the sideline. So he makes that angle of 38 degrees to the sideline. Okay, so again, if we wanted to draw these as vectors, we started with this 30-meter kick, moving down the sideline in the, we're going to say in the direction to the right, and then it went an angle of 38. The ball continued moving forward though, further down the field. So we'd have vectors that look like that. It says determine the magnitude of the resultant. So remember, our magnitude is the length of our resultant, and our resultant is going to be drawn from the tail of our first vector to the head of our second vector. So we're going to label that as our resultant, and we're going to see if there's any other information that we can fill in here. If I know that this outside angle is 38 degrees, I should be able to find this angle here. So those two angles are going to equal 180. So I should be able to do 180 minus 38, which equals 142. So this angle here is 142 degrees. So looking at the triangle I've created here, I have side, angle, side. So we're going to use cosine law. So r squared is going to be equal to the square, the sum of the squares of the other two sides, minus 2 times those side lengths, times the cosine of the angle across from the side we're trying to find, so the cosine of 142. If we calculate all that, we should get 2,245 point, bunch of numbers after a decimal, 612,904. Don't round it to the end. And then we'll take the square root of both sides to isolate for r. So we should find that r is equal to 47.4 meters. Okay, the next question says, determine the direction of the displacement of the soccer ball. So remember that when we're talking about direction, okay, direction is another word for quadrant bearing. So they're not looking for a true bearing here. In this case, they're looking for a quadrant bearing. So they're wanting us to find something in terms of this resultant here. So we have to kind of look at what's going on here. If I was to draw a compass, we know that initially we are being kicked down the field. So if we labeled that down the field as moving in an east direction, right, because it was parallel to that sideline, then we need to determine, here's my north, this is going to be our quadrant bearing. Of our resultant. Right, we have our resultant going from the tail of our first vector to the head of the other one. So that's going to be our quadrant bearing, but we're going to need to find some information to help us with that. So we could put theta inside our triangle, and once we've identified that, then maybe we can work to find our quadrant bearing. So if I put theta there, I've determined that r is 47.4. So now that I have a side and an angle pair, I can use sine law. So let's set up sine law. We'll say that the sine of theta is divided by the side across from it, which is 20, is going to be equal to another side angle pair. So we'll say the sine of 142 over 47.4. I'm going to multiply that 20 over to the other side. And then we'll take this sine inverse in order to isolate theta. So the sine inverse of 20 times the sine of 42, or sorry, that's a 142. Get that. I missed a 1 up there. All over 47.4. And when we take the sine inverse of all of that, we should get 15 degrees. So this is our angle made with the horizontal. But again, we want to figure out our quadrant bearing, right? So our quadrant bearing there is going to be 90 minus that. So our quadrant bearing is going to equal 90 minus that 15-degree angle made with the horizontal, which is 75 degrees. And again, if we look back at our compass, we can see that we're moving in a northeast direction. So we're saying north 75 degrees east. So to summarize the displacement of this resultant, we could say, therefore, the displacement of the resultant is 47.4 meters on a quadrant bearing of north 75 degrees east. Okay, so that wraps up our note for today. Just remember that we're trying to set up these triangles based on the magnitude and direction that's provided to us in the question, and then identify what the resultant or the bearing using what we know about trigonometry. So in terms of SOHCAHTOA, or sine law, cosine law, Pythagorean theorem. And that's it for today.